Hello friends, in the previous lecture we have seen that what is meant by prime numbers and composite numbers. Also we have studied Euclid's lemma. Today I am going to start new point, relation and equivalence relation. So let us start new point, relation and equivalence relation. Before that I am going to discuss about you what is meant by Cartesian product. So I am going to start new definition. Cartesian product. For that Cartesian product, we must require what is meant by order pair. Okay. So what is meant by order pair? Okay. So this is our definition. Let capital X and capital Y. Let capital X and capital Y be two non-empty sets. Let capital X and capital Y be two non-empty sets, and small x belongs in capital X, small x belongs in capital X, and small y belongs in capital Y. Small x belongs in capital X and small y belongs in capital Y. Then the pair x comma y is called as ordered pair. Then the pair x comma y is called as ordered pair. Okay. Now, what is meant by equality of two pairs? Therefore, next point. Equality of two pairs. Equality of two pairs. So what do you mean by equality of two pairs? Okay. If two pairs x comma y and x dash comma y dash. If two pairs x comma y and x dash comma y are said to be equal, if and only when these two pairs are said to be equal, if x equal to x dash and y equal to y dash. When these two pairs are equal, if x equal to x dash and y equal to y dash, that means corresponding elements are equal. That is corresponding elements are equal. Okay. What is the two pairs are equal? If pair x comma y equal to x dash comma y dash, these two pairs are equal. When these two pairs are equal, if and only corresponding elements, that is x equal to x dash and y equal to y dash, if this condition are hold, then these two pairs are equal. Right? We just take the example. That is 1, 2 and 1, 2. These two pairs are equal, right? 1, 2 and 1, 2. These two pairs are equal. When these two pairs are equal, even only 1 equal to 1 and 2 equal to 2. Both conditions are hold. Therefore, these two pairs are equal. So this take a second example. 1, 2, 3 is it equal to 4, 5? No, these two pairs are not equal. Why? Because these two pairs are not equal because 2 is not equal to 4 and 3 is not equal to 5. These two pairs are not equal. If these two pairs are equal because elements are same. If elements are not equal. Okay. So let us take the next point. What is meant by Cartesian product? What is meant by Cartesian product. Write down next definition. What is meant by Cartesian product? Write down definition. Cartesian product. What is meant by Cartesian product? Write down definition. Let capital X and capital Y. Let capital X and capital Y be two non-empty sets. Be two non-empty sets. Let capital X and capital Y be two non-empty sets. Okay. Then the Cartesian product. Then the Cartesian product. Then the Cartesian product of two non-empty sets. Then Cartesian product of two non-empty sets. Then the Cartesian product of two non-empty sets is. Then the Cartesian product of two non-empty sets is denoted as x cross y. What is your Cartesian product? Cartesian product of two non-empty sets is denoted as x cross y and it's defined as set of all ordered pairs. Is set of all ordered pairs of x and y, where x is the element of capital X and y is the element of capital Y. What is the Cartesian product? X and y being two non-empty sets. Then Cartesian product of two non-empty sets x and y is denoted as x cross y, and it is the collection of all ordered pairs of x and y, where x is member of x and small y is member of y. That is Cartesian product of x cross y. That is Cartesian product of x cross y is collection of all ordered pairs. It is the collection of all ordered pairs x, y such that where small x is member of capital X and small y is member of capital Y. This is your Cartesian product. Okay. Now, if I don't know, if x contain m elements, if x contains m elements and y contains m elements, then if x contains m elements and y contains n elements, then Cartesian product x cross y contains, the Cartesian product x cross y is contains m into n elements. How many elements in that Cartesian product? That is mn element. Okay. If x contains m element, y contains n elements, then Cartesian product x cross y contains mn elements. Okay. Let us take the example. If your set x contains small a, small b and small c, okay, containing three elements, and if y contains two elements, that is 1, 2, okay, y contains two elements, that is 1, 2, then x cross y, then your Cartesian product of x cross y is collection of all ordered pairs x, y. Take first a, x element is a, then take y's first element is 1. Then take x first element is also a and y its second element is 2. Next element x containing element b, y containing element 1. Next b, y containing 2. Next third element is c of x and y containing first element is a 1. Next x containing element last element c and y containing element last element is 2. There is how many elements in the Cartesian product? X, by using this remark, if x containing 3 elements, y containing 2 elements, then x cross y containing 3 cross 2, that is 6 elements. 1, 2, 3, 4, 5, 6. Therefore, x y containing 6 elements. Now this is your x cross y. If we want to find y cross x, then what is your y cross x? If we want to find y cross x, therefore y cross x is become containing first element of y. What is first element of y? That is 1. So you have to take 1. First element of x become a. Okay, next first element of y is 1. Second element is b. Therefore 1 comma b. Next 1 comma c. Okay, this is your first element of y. Now second element of y is 2. Therefore this containing 2a, 2b and 2c. Okay, so how many elements in y cross x? Also 2 cross 3, that is 6 also. Okay, from this one as star, this is your double star. Okay, from star and double star, from star and double star. What is your first pair? 1 comma a. In x plus y, containing first pair is a comma 1. Okay, and here first pair containing 1 comma a. Is it both pair equal? These two pairs are not equal, because when these two pairs are equal, if a equal to 1 and here 1 equal to a, therefore is it both pair are equal? No. So therefore from this conclusion, x cross y is not equal to y cross x. From this conclusion, what do we get? Cartesian product of x cross y is not equal to y cross x. That means Cartesian product is not commutative, right? That is Cartesian product. Cartesian product is not commutative, right? The Cartesian product is not commutative, right? Now let us take the next remark. If x contains m elements, then Cartesian product x cross x, then Cartesian product x cross x contains how many elements? X containing m element. There is also x containing m element. Then how many elements in x cross x? That is m into m, that is m square. Contains how many elements? That is m square, right? What is your x cross x set? And x cross x set is collection of all x comma y such that where x and y is member of x, right? What is your x cross x? That is Cartesian product of x itself to itself, containing all those where x, y such that x and y is member of capital X. This is your Cartesian product of itself. Okay. Now let us now take this is Cartesian product for two sets. If there are n sets, okay. This is Cartesian product for two sets. If there are n sets, then what is Cartesian product for n sets become? Okay. So write up if this is what if a1 a2 up to dot an are n non-empty sets, okay. if capital A1, capital A2 capital A are n non-empty sets, then Cartesian products, Cartesian product of A1, A2, up to AN. Then Cartesian product of A1, A2, up to AN is denoted as how do you Cartesian product? A1 cross A2 cross up to cross AN. This is the Cartesian product of n non-empty sets, and is defined as, so Cartesian product of A1 cross A2 cross up to cross AN equal to, this is your Cartesian product of A1 cross A2 cross up to AN equal to x1 x2 up to xn, right? That is n the power. Cartesian product of n sets become collection of all n tuples x1, x2, up to xn, such that here xi belongs in Ai, where xi belongs in Ai, and I run from 1, 2, 2, n. Okay, this is your members. This is your Cartesian product of n sets. Okay, now let us, I am going to take what is meant by relation. Okay, so next definition is relation. What do you mean by relation? Okay, what do you mean by relation? Okay, second definition: a relation from set x to set y. A relation from set x to set y is defined. A relation from set x to set y is defined to be any subset of. A relation from set x to set y is defined to be any subset of x cross y. What is my relation? A relation from set x to set y is any subset of. What is my relation? Relation is any subset of x cross y. Then this is called as relation. Okay. So let's take example. If your set x become, that is a Ram, Shyam and Vinit. If set x containing the peoples whose names are Ram, Shyam and Vinit. Okay, and if your set y become Pune, Nasik and Mumbai. Okay, if your set y containing the cities, that is Pune, Nasik and Mumbai. Okay, where these three peoples are live. Okay, then x cross y become, then x cross y is Cartesian product of x y containing how many elements in that x cross y? X contains 3 elements, y also contains 3 elements. So total number of elements in Cartesian product become 3 cross 3 become 9 elements in the Cartesian product. So with these 3 elements, with these 9 elements, first take a Ram with Pune, right? Second element is a Ram with Nasik. Next is a Ram live in Mumbai. Next, take a second element is Shyam. Shyam is live in Pune. Right. Next, Shyam is live in Nasik. What is the last third one? Shyam live in Mumbai. Next, last 3 events. Next, last event is Vinit. Vinit live in first element is Pune. Next, Vinit live in Nashik. What is the last third one? Vinit live in Mumbai. Okay. These 3 are your native places of these 3 persons. Okay. This is your Cartesian product of x cross y. Now that is, I have to define what is the relation. So that relation become R become. You can make the relation define. That 3 people. There is Ram live in Pune. Second is Shyam lives in Nashik. And last third one, that is Vinit lives in Mumbai. Therefore, is it a R is a relation? Then R is a relation. Then R is a relation from X to set Y. Yes? Yes. Is it R is a relation? Yes. What is relation? What is the relation? Relation means it is any subset of x cross y. This is your x cross y set containing the 9 element in the relation R. We have to take any 3 elements. That is Ram is native place. Ram is native place is Pune. Shyam native place is Nashik. And Vinit is native place is Mumbai. This is the subset of x cross y. Yes. Therefore R is a relation. Okay. Now relation means you have to take any subset of x cross y. Okay. So that is our remark. That means your remark is become if x containing your m element, y containing n elements, then how many relations from x to y? Okay. Then how many relations in x cross y? So what is your remark? Write down remark. If x contain m element, if set x contain m element, set y contain n elements, then how many relations from x to y? Then number of relations. The number of relations from set x. The number of relations from set x to set y is, we have to find number of relations from set x to set y. So how many relations from set x to set y is? So what is how many subset of x cross y? Now if set x containing m element, then set y containing n element, then x cross y, your x cross y contain how many elements? Mn elements, right? Your x cross y contain mn elements. And how many relations from x to y? X cross y relation is any subset of x cross y. That means we have to take all subset of x cross y. So how many subset of x cross y? Therefore, subsets of x cross y is subsets of x cross y is how many subset of x cross y? That is 2 raised to m into n. So how many subset of x cross y? That is 2 raised to mn subset. That is power set of x cross y. What is power set of x cross y? Contain how many elements? The 2 raised to mn. Therefore, number of relations. Therefore, number of relation, number of relation from set X to set Y. We have to find the number of relation from set X to set Y. How many relation from set X to set Y? That is number of subsets. So how many subsets? It is 2 raised to mn subsets, right? Therefore, number of relation from set X to set Y is 2 raised to mn. So how many relation from set X to set Y? That is 2 raised to mn relations. Okay? If X contains m element and Y contains n element, that is total number of relations. If second lemma, now we have to write down second lemma, that is if number of relation from set X to itself. Then what is your second lemma? This is your first lemma. We have to write down second lemma. If X contains m elements, if X contains m elements, then number of relations from set X to itself. That means we have to find the relation from set X to itself. How many relations from set X to itself is? How many relations? That is 2 raised to m square. How many relations from the set X to itself? How many relations? That is 2 raised to m square. How this come? Because set X containing m element, then Cartesian product of X cross X. Cartesian product of X cross X, that is collection of all order pair X1 such that X and Y is member of X, right? So how many elements in that X cross X? That is m cross m. So how many elements in that X cross X containing how many elements? That is m square element, right? So therefore subsets of X cross X, right? That is the relation from X to X. It becomes collection of all subset of X cross X. So subset of X cross X is how many subset of X cross X? That is 2 raised to m square. How many elements? That is m square element. Then how many subset? That is 2 raised to number of that element. The coordinate of X cross X. The coordinate of X cross X is m square. So how many subset of X cross X? That is 2 raised to m square. Therefore, how many relation from set X to X? That is 2 raised to m square relation. Okay? It is so easy. So we have to study relation. Next point we have to study what is meant by reflexive relation. Okay? This is right now. Next point is reflexive relation. What do you mean by reflexive relation? Okay? It is so easy for a reflexive relation. And one definition. Reflexive relation. What do you mean by a reflexive relation? Okay? A relation R on set X. A relation R on set X is said to be reflexive relation. A relation R on set X is said to be reflexive relation. If X comma Y is element of R, if X is member of R, then X cross X is a member of R. Then this relation is reflexive relation. Okay? What is a reflexive relation? A relation R on set X is said to be reflexive relation if X is member of R, then the order pair x comma x is belongs in R, then this relation is said to be reflexive relation. That means the element and itself, the order pair is member of x, then this relation is said to be reflexive relation. Let us take the example. Let capital X, let the set capital X be the set of all lines, be the set of all lines in a plane. Okay, let X be the set of all lines in a plane, and define a relation R on X is, or define a relation R on set X is X related to Y if we have defined the relation R on set X is related to Y if X is parallel, if line X is parallel to line Y. Okay, what is the relation defined? X is set of all lines in the plane. We have defined a relation R on set X. We have defined relation. How to define relation? X is related to Y if line X is parallel to line Y. This is your relation X related to Y. Okay, and if it is, therefore, is it your R is reflexive relation? What is the reflexive relation? If X comma X is member of R, right? Therefore, R is reflexive relation. R is reflexive relation because, why is it reflexive relation? Because X is related to X. When is it reflexive relation? X is related to X, right? That is, X comma X is member of R. Yes, X comma X is member of R. That is because if we are given this line, X line, okay, this is your X line, right? And this X line is parallel to your Y is also X. This X line is parallel to itself. Yes, therefore this line is parallel to itself. Therefore X comma X is member of R. Therefore X is related to X. That means R is your reflexive relation. Okay, it is so simple. So next point is your symmetric relation, and third point is your transitive relation. And if this relation R is reflexive, symmetric and transitive, then this relation is said to be equivalence relation. So remaining part we also study in next lecture. Thank you.